Hi, today we are going to discuss exception in a Java. So what is mean by exception in Java? An exception means an exceptional condition and it is occur in the normal program flow, which means this exception can occur because of our bad programming or lack of resources or network issues or some wrong method call or wrong parameter passed or wrong value passed. So because of these conditions, there could be an exceptional condition or there would be an occurrence that may lead to the normal normal flow of the program will be affected. So these conditions are we are called, or the situations we are called as an exception. So whenever an exception occurred, there is an option to handle in Java. So there is a very robust methods, robust procedure is there to handle in Java. So before that, there is we are already defined or there is already inbuilt exceptions are there as part of Java libraries. So as we know that all classes are the child of the object class. Here as well, we can see that object is the super class of all exception classes. So immediately the immediate child of the one of the class is the throwable. Okay, so all exception in Java are the child of the throwable class. Further, this throwable class is divided into two. One is exception and rightmost side it is the error. So what is the difference between the exception and error in the exception in the Java? The exceptions are due to our programming, bad programming or something wrong evaluation, wrong method call, something like that. But the error on the right hand side of this error occurring due to the lack of resources or environment issue where the program is runs. So those issues, for example, the memory issue, while the program is running, the program may need a particular amount of this memory is required. So there could be a chances that the lack of memory is there, available memory will be very less. So in that situations, those exception are comes under the error. So those exception may lead to termination of the program, which means they immediately it will exit the program, the normal flow of the program. So those exception we can't handle in the program itself. So those are the exception under the error class. So those exception we are not going to handle those. If they occur, definitely the program may terminate. The other side of the exception are again further divided into multiple classes, that is a runtime exception, IO exception, SQL exception, and ADWT exception. So again, we can see that the runtime exception is again divided into multiple classes, the arithmetic exception, null pointer exception, class catch exception, etc. IO exception is also related to that. Further, these we are divided into multiple, two categories. As mentioned here, the marked section are called unchecked exceptions. And again, the other class category comes into the checked exceptions. So what is the checked exception means? The checked exception means that whenever the compiler compiles, compiling time, it will we have to handle compiler itself will complain about this exception or not handled. So compile time itself we have to mention either we have to handle it or we have to declare that is those kind of exception is known as checked exceptions. All other exceptions are called as unchecked exception. So we are not forced to handle those those exceptions. All checked exception we need to handle. So we can see the example in here. How do we can handle those exceptions or how we can handle that exceptions here. In Java, exceptions are handled by try, catch, finally, throw, throws keyword. So what is these keywords are used, or how we are using in the uh, these keywords for handling the uh, exception handling? We can um, use one of the examples. So here I have created one package com.java.training.exception.demo. Okay, so there is one, I created one class, that is the exception demo class. Here what I am trying to do is that I have declared three variables, that is integer value 1, value 2, which is initialized to 10 and 0. Okay, and what I'm trying to do here is that these both, here you can see that value of value 2 is equal to 0. Okay, so here what I'm doing is that I'm dividing the value 1 by value 2, and that result is going to save here and assigning that variable to the result. Okay, so we can see that we already knows that whenever we do the arithmetic, I mean when we do the division, there will be an exception will be okay. Okay, so let's have try run this example without the other part of the program. I'm just commenting that one. Okay, so here I'm dividing the two variables, value 1 by value 2, and assigning that value to result. Let's run this example. Okay, so we can, let's see what is the result of this uh, execution. See, here we can see that there is one exception occurred. Okay, so when we exception occurred, we can come to know that in the console it is saying that there is one arithmetic exception. So we can see that what kind of exception it is. So it is arithmetic exception. How it is occurred? It is occurred by the division of 0. Okay, and from where this exception occurred, that is also matters. Okay, so from this stack trace, this is known as the stack trace. So this is occurred the line number 11 in the exception demo.java class. What is the line number 11? It is the result is equal to value 1 by value 2. This is all we can tell that this is the stack trace of this particular exception. So here we can see that by division by the 0, it and this arithmetic exception terminated the flow of the program. For example, if there is any other statements or any other code that we supposed to execute, that is not executed actually. So let's, I'm printing here system.out.println, and I'm printing the result of that one, and let's run. Here we can see that the result statement, or whatever the output we got, or whatever be the value we initialize by 0, right? So that is not going, I mean that is didn't print here in the console, which means that whenever the exception occurred, the program is terminated. So we have to handle this exception in the program in order to execute the whole program. Okay, so there is a proper way of handling is that, so that we are using the try catch block. So try catch are we are using for handling the exceptions. Okay, so let's have the example here, what it is mean by or how we can use the try catch. So I'm commenting out the previous result which terminate the code. Okay, so the syntax of the try catch is like this. Whatever or whichever the code, which the line of the code which is going to give us a exception, or the code that is resulting in the exception, are writing in the try block. Okay, so the syntax of the try is try the curly bracket. In this block we are writing all the code which may lead to the exception. Okay, here the result is equal to value 1 by value 2. So that is the division is going exception. So that code we written in the try block. Okay, So the exception, we already know that this is going to the arithmetic exception, but we know that what kind of the exception is going to catch is going to handle. In catch block, the syntax is like this: catch whatever the exception. Here it is, I generalize the exception. This is the java.lang.exception, that is the going to print. We already know that all exception, or we can say that all runtime, I mean every exception is the subclass of the exception. Again, this exception class itself the subclass of the throwable. All others are under the exception class. And the error class on right hand side, that is another exception or another error, which is we are not going to handle, because that is not because of the our program or our coding program, our coding issue or anything like that. So here I generalized the exception. The arithmetic exception is the subclass of the exception class itself. So top exception type, that is the exception class I handle here. So what I'm doing here, I'm just printing the system.out.println. Just run this. So we here what happened, the result is equal to value 1 by value 2 ended up here. Already the arithmetic exception we already seen in the previous trial of the code in the itself. So that code terminated actually, but here that is didn't happen. Whenever the result is equal to value 1 by value 2, result in the arithmetic exception, that exception catched by the catch block, and the catch block is going to return the message saying that exception occurred. Okay, so we can say that we already handled that exception. So in order to get better message from the exception, what kind of exception occurred, we can use the e.get message. So here we can see that the exception is due to by zero division. Okay, so that is the exception occurs slash by zero mentioned. This, the operation is the division, and what caused the arithmetic exception, it is by zero. Okay, so therefore that we can use the get exception method from the exception class. We can also use the print, we can print the all the stack trace itself. Okay, so which will give us more detail about the exception, what exception, why this caused, what is the type of the exception, etc. Here it is giving us the issue, I mean the compiler telling that it's already printing into the console, so we don't need again writing into this console using the system.out.println. Okay, after that I'm also printing one message also. Okay, I'm writing system.out.println, and this message is say that exception handled. Okay, so the general flow is that exception okay, exception will be printed. So we can see that exception occurred, whatever the exception, that is by zero, then exception handle, and then actually this print this print stack trace supposed to be print on top of the exception handle, but this is because of we are pushing, or the exception print stack trace supposed to be print into the console, so that is the delay in the output stream. Okay, for that we can use the one pause in the execution by using the thread. We will come to know how to what is the thread means in our thread section, but for the time being we can use the sleep method from the thread class, which will cause the pausing the execution by 1000 millisecond. Okay, so here it is complaining that it is supposed to either throws, or we have to handle that one. So we are using, or we are handling using the try catch. Okay, so let's run this method. So we can see that here it is properly printed, means we post that thread, and which that is caused to push the data in the output stream. Okay, so here the result arithmetic exception happened, and that exception is the subclass of the exception type, and the exception here handled in the catch block. Okay, which is the super class of all the exception. Okay, and that's we handle nicely here in this code. Okay, So let's see this code. We can see that we want to write this message at the end of the program execution. Okay, for that we, to make sure that we use the thread class to sleep that method for the seconds, we can again increase that sleeping time, which means it's a 20 milliseconds. We can see that it paused that execution a little while, and then the message, the final message printed what is mean by the exception handle. Okay, so actually we can see that the final message to print, do we need to write this thread class, or do we need to post that thread actually to print the final message to get print? No, there is a way is that. So let's have then example, I mean let's try. So in order to print that exception final message, we can use the another way to uh, print the same result. Okay, so that is achieved by, I'm just commenting out the code, and that is achieved by the finally keyword. So what is the finally keyword is used for? The syntax of the finally keyword usage is that, as previous, whatever code that is going to give us the exception that is writing in the try block, that is value, I mean that is value divided by value 2, so which will result to arithmetic exception, which is handled by the catch block, and the finally block is written here, that will write the message saying that finally block. Okay, so the finally block will be executed, or print here, it is a printing, the finally block will be executed even though if we handle the exception in the catch block, that is system.out.println exception. Okay, so in this in here, this will be how it will be executed. The result is equal to value 1 by value 2 will be a, will cause the exception, and then that will be handled in the catch block, and in the finally block, the this finally block will be, the message will be printed by the system.out.println. Okay, let's try, I mean let's run this example. I'm just commenting out the another message also. Okay, so here we can see that the message is getting printed, the exception handle and exception occurred, etc. Here we can see that uh, there is also chances are there in the catch block itself, there can be exception occurrence of the exception. So I'm doing, okay, here I'm doing the one more time the valuation. I'm just commenting the previous code, and here what I'm doing is that in the try block I'm running the uh, division by the value 1 by value 2 and assigning that, then there will be arithmetic exception will be there, that will be handled by the catch block, and catch block is again result, I mean again rerunning that one. So what will happen, the catch block is again result in the exception occurrence, correct? Again we can see that even though in the catch block the exception occurred, in the finally block is getting executed. Okay, previously the program will be terminated. Here we can see that the exception occurred block is, I mean the statement is not printed, because the result is equal to value 1 by value 2, which lead to the arithmetic exception, so this statement will not be printing, but it will make sure that the finally block getting executed. And this stack trace is printing the uh, below, it's because of the result, I mean the 30th line, because of the 30th line that is causing the arithmetic exception, so that is directly printing here. So that is the reason it's printing here the arithmetic exception, I mean um, this message is getting printed. So we can say that the finally block is executed even though if we handle the exception. Okay, so there should be mandatory, or we can say that either we handle the exception by the catch block, never matter, the finally block will be executed. So do we really need handling the exception by catch block? The answer is no, not required, because in generally the best practice is that whenever the exception occurred, we need to print that exception in the console, or I mean we have to handle that one. But in some cases we need to handle the final message whether the method executed or not. So for that we need the finally block. So as mentioned earlier, do we need really handling the catch? Okay, so actually we don't need, even though without the catch block itself we can handle the exception. In the handle the exception in the sense, whenever the exception okay, we are not handling that one, but some we'll make sure that some code, I mean the final message will be executed in the finally method. We are not handling here, okay, we are not handling the exception here, but the finally block will be executed. Here we can see that the finally block is executed. That is try without the catch block is the string that is getting printed on top, and the result is equal to value 1 by value 2. That's lead to the arithmetic exception. That is the printing here in the console, because we are not handled that exception, so directly it is printing into the console. Okay, but the finally block, okay, the finally block message is getting printed. Why this is printing at the top, I mean before the arithmetic? It's because of the output stream pushing into the console. That's the reason. If you rerun again, it may be there will be change. We can see that this is because of our CPU, I mean in our system, that is the time cycles issue. It is not, don't worry about this. In our case the flow will be in this like this, the finally block will be executed last only. Okay, but here in the console, because of the output stream that is writing the a little bit lower than the actual flow of that code. Okay, so this is how we are handling the our exceptions in using try catch finally keywords, using the try catch finally keywords. Okay, so here we see that our exceptions, we generalize the the exception, correct? We are used to the exception class, that is the top class, or we can see that parent class of all the uh, exceptions in general way. So we in best practices we can say that we have to handle the specific exception in order in alternative way, that we used the parent method, generalized the method, generalized the exception. Instead of that, we should specify what exception is going to occur, and we have to handle it in that such a way. So here we can see that the exceptions, arithmetic exceptions and everything is under the exception, and it's under the runtime exception. Runtime exception again have the subclasses, correct? So this runtime, the flow is that child should be handled first. We can see then runtime exception is the child class of this exception class, correct? Exception is the parent class, runtime is exception is the child class. So the child class should be handled first, then the higher class, higher exception class should be handled. So this is how the multiple catch is handling. Okay, so runtime exception, here again here we know that result is equal to value 1 by value 2 leads to the arithmetic exception. So arithmetic exception is again subclass of the runtime exception. So what will be the result when we run this program? Okay, because the result is equal to value 1 by value 2 will give the arithmetic expression, which catch block will be executed here. Okay, so we can say that the runtime exception will be, that catch will be handled, that exception arithmetic expression, because that is the most specific or most appropriate exception class for the arithmetic exception. Even though Arithmetic exception is the subclass of the runtime and exception class, though it will be most specific exception class is the runtime exception. That is the while running this example, we can see that runtime exception. Okay, because this is because result is equal to value by value one, that is arithmetic exception. So arithmetic exception immediate parent, that is the runtime exception. So that's the reason this runtime exception catch block is executed. Again, as per the syntax, if we are trying to print one message system.out.println before the catch block, okay, before the catch block, it will say that there is a syntax error actually. That means immediately after the try block, catch block should be there. Okay, it should not be any other statement. Okay, if you write any other block, it will be uh, show you the error telling that immediately it should be catch block. Okay, in Java 7 we use the multiple catch, right? So instead of that we can use multiple exception in a single catch block itself. Here I am doing some file operations where the file is going to read this from this file.txt file, where this file.txt file is not existing by. Okay, file reader, what it will do, file reader try to read the file.txt. So what will happen there, the as the file is not there, the file not found exception will be occurred. Again, this file not exception is the subclass of the runtime exception. So there could be another exception also may occur in this try block. So all the exception, whatever exception is going to throw from the try block, that we can handle in the single catch block itself. So what is the advantage of handling this one? Because here we can see that multiple catch block is there. In reality, there should be more code or more logic will be there to handle the exception. Here we are just printing the message, but here we can say that for the readability and I mean it will be very short in code wise itself, so it will be very easy to handle that one. So we can say that by printing the message we will get a clear idea what is the causing this issue. So here the file.txt is not existing, so that is every exception we are handled under the same catch. So that is the one of the enhancement from the Java 7 onwards. So in Java 7, there is a enhancement in multiple catch, uh, multiple catch handling. Okay, so it is very useful actually. Uh, in, in addition, I mean, instead of the multiple catch block. Okay, now we already talked about the checked exception. So let's have one example. I have one class here, it's a checked exception demo. Here what I'm trying to do is that file is equal to file new file txt. So this file is not existing. Okay, so again this compiler is complaining about, there is a complaining telling that there is some error is going, because this error is showing because I'm using the Eclipse. In reality, if you use the Notepad, it won't. We won't come to know. I mean, while coding, but in Eclipse saying that there is some error. Why this is error? The the compiler be complaining about that this is a checked exception. While reading this file, there could be chances of the file not exist. I mean, file not exist. Okay, if the file is not exist means that is already compiler know this, the whatever the I mean compiler already know the kind of exception that is going to generate or that is going to throw by this code. So what we have to do, we have to handle that exception. Okay, so in order to handle that one, we there is a two way. That is the one is that add throws declaration or by the surround by the try catch. Okay, so he either we can tell the compiler telling that we know that it will throw the exception. Well, let's I mean let's keep it as it is. Okay, we are not going to handle that one. Okay, or we can handle that exception. Okay, so if we use the throws keyword, we are telling the compiler that we know that as a programmer we know that this program will throw the file not found exception and keep it, let it be as it is. But for the time being, I'm handling by the try catch. Okay, in the try catch, what I'm doing is that what which is the code is going to cause the exception. This exception is caused here. We can see that the file not found exception is is the checked exception, correct? It is not under the runtime exception, we can see. So that is file not found exception. Okay, in previous example it is a we can see that result is equal to value 1 by value 2. It caused the arithmetic exception, correct? So here we can see that the compiler is not complaining because that is not the checked exception. But here this kind of exception, file not found exception, is a checked exception. So the checked exception we have to handle either through the try catch or we can use the throws keyword. So here this is I used the try catch method. So that is way that is going to handle that exception here. So all checked exception we have to handle. Otherwise the compiler will complain. While compiling, it will give you the error saying that this exception is not handled. Okay, so that is why all checked exception we have to handle. As a program, we have to handle that exception. Okay, so till now we are talked about the exception already knows in the or already available in the Java. Here we are going to create our own custom exception. Okay, so I created one class that is known as the custom exception that extends the exception class. Okay, so this custom exception or our own any other exception, we can name any other exception which is the subclass of any of the exception. Here I made it says exception, and I have here one message, string message is there, that is initialized in this constructor. Okay, you see in this constructor I have used the keyword is super. Why we are using super? Super keyword is used as part of the object creation chaining. This super will be the immediate first call, I mean in the constructor, and this will call the super class constructor having the same parameter. Okay, so that will be initialized. Okay, so before creating the custom exception we are calling, I mean constructor, we are calling the super constructor. And here we have the another method is get message. So this is simple sorry, this is a very simple custom exception used or created for our own to um, demo the throws. Okay, here in uh, previous early we just saw then how we handle the exception. So we saw that try catch finally and throws also. Now we can see that what is the how we can handle using the throw. Okay, so there is a scenario that we need to throw our own custom exception. For example, if there is a web application or any other application that uses username and password, if we enter the username and password correctly, that will lead to another, I mean subsequent pages or subsequent actions. If we didn't pass the correct username and password, it will give us the message saying that the username and password is not correct. So how do we can handle those scenario? That we can do through the custom exception. Okay, so what the custom exception do, whenever we enter the username and password, if it is a wrong, saying that it is not matching the actual username and password, we will throw the custom exception telling that the username password thrown, I mean username password provided in the application is a wrong. Okay, so that is the one of the scenario, real scenario using the custom exceptions. So in the custom, not only that, in many other scenario, many other contexts also we can use the custom exception. So how do we create that custom exception? We just saw the using the extending any of the exception class. So here we extended by the exception exception class. So here I just created for the demo purpose. I'm just throwing the custom exception directly. Okay, so there is no logic of creating any other one. So here we can see that the custom exception extends the exception. So I'm just throwing this exception simply for the demo purpose. Okay, so the first code itself, the throwing the exception, which will be handled by the catch block. Okay, in the catch block, what kind of the exception is going to handle? That is the exception which we use, which we are throwing. Okay, so what is that exception? That exception is the custom exception. Okay, here um just we can have one, say, a real program. We can print that exception. Oh, in the real case, what is that exception occurred or during the username, password, or anything like that. So here I just print out in the console saying that here the exception. Okay, after that I'm throwing this exception. Okay, so real case, what will be the logic will be here, right? The logic will be the here real case. For example, logic in the validating the username and the password. Correct. If the username and password is not correct, then what we are going, we are throwing the custom exception. Okay, so once the throw the exception, that exception will be handled in the catch block. Here we just printing the exception. Okay, after that we are throwing this exception again. We are not holding the exception, or we are not suppressing that exception here. We are rethrowing this exception. Okay, so in order to rethrow, we already throw the exception in the try block, and which is handled again in the catch block itself. Correct, but again we are rethrowing. So the compiler will complain about that. Why you are again rethrowing? We already thrown in the try class, and that is, I mean, we handled in the catch. Correct. Let's have one. I'm just commenting this code, and I'm just throwing the custom exception. Yeah, to throw. Okay, this is my custom exception. Okay, I'm just removing this throw statement. So we can see that the compiler will complain saying that you need to either, so the what you do, you need to, you're throwing this exception, so either you need to declare that exception. Whoever is using the demo, they will come to know this method is going to throw this exception, or you have to handle. So here I am going to handle that one, because our logic is the username password. Okay, so I'm just deleting that code. So here I'm going to handle that one. I don't need to print the stack trace. So here I'm printing the message saying that exception is okay. Okay, and after that I need to pass this exception into client side, or whoever is using the, or whoever is calling the demo method. So I'm throwing this exception. While doing this, the compiler will tell again, will complain that you already handled that exception. Okay, that exception E from the try block. Okay, that exception is is the custom exception, and you are again rethrowing. So you should do one thing, or you should handle that except throwing the exception. So how do we can add again? We one time we already handled, so we need to make sure that this exception is going to throw the exception. What kind of the exception is a custom exception? So we should throw this exception. Why throw statement is used here? It is indication telling to the compiler as well as the user who is using the demo, telling that this method is may throw the custom exception. You have to expect that the message, I mean this demo method will throw the exception. So these are the keywords for handling the exception.
If you like the video, please click the like button and subscribe for more videos.